All right, let's jump straight into this architectural teardown of SkillsHome. We are looking at a system today that tackles a really universal gap. How exactly do we represent our professional selves in the digital age? Well, SkillsHome is an AI-verifiable personal branding platform, and it literally takes your raw resumes and GitHub repos and turns them into continuously scored living profiles. Now, in this explainer, we aren't just going to talk high-level theory. We're actually popping the hood to look at the shipped code and the production architecture to see exactly how a real AI SaaS product is wired together.
So here's our roadmap for the explainer. First up, reinventing personal branding. Then we'll map out the core architecture blueprint, followed by a deep dive into using local LLMs for ultimate privacy. After that, we'll trace the AI ingestion pipeline, unpack the RAG architecture for chatting with profiles, and finally, my favorite part, we'll expose some real-world engineering truths. Let's get right into it.
Section 1, Reinventing Personal Branding. The problem and the promise.
Okay, we have to start by addressing a massive gap in the market. Right now, there's just no definitive platform for dynamic, verified personal branding. Let's be honest, static resumes are basically dead. They are completely outdated the literal second you export them to a PDF, right? SkillsHome is stepping in to solve this by acting as a living profile platform. It continually scores and verifies your exact skills based on real hard data. We're talking actual GitHub commits and work history. It takes a stale document and breathes life into it, turning it into a dynamic, AI-verified entity.
Section 2, The Core Architecture Blueprint. Let's see what's under the hood. The stack we're dealing with here beautifully illustrates the pragmatic foundation of the platform. We aren't looking at some bloated, over-engineered mess. It's incredibly focused. You've got Next.js with the app router handling the front end, while PostgreSQL, managed via Prisma, acts as the absolute single source of truth. Then there's Redis pulling triple duty as a read-through cache, a session store, and the backing store for background jobs. And to coordinate all those jobs, they're using BullMQ, a distributed queue written in TypeScript. It is just a lean, highly effective setup.
Section 3, Local LLMs for ultimate privacy, keeping your data yours.
Now, in an era where users are, understandably, incredibly wary of feeding their entire personal work histories into these opaque cloud models, this architecture takes a rather radical path. It utilizes a llama. If you're not familiar, this is a local LLM runtime that allows the system to run open-weight and embedding models directly on their own hardware. And the result of that? Well, you get zero per token cost for inference, which is great for the business, but more importantly for the user, zero data ever leaves the box.
And you know, this local-first approach builds instant trust. Just think about it. With cloud LLMs, your data is completely out of your hands. The pricing is highly unpredictable, and the privacy risks are just baked right in. But with Ollama, SkillsHome achieves complete data sovereignty while fixing their hardware costs. They are protecting the user's personal brand at a fundamental architectural level. It's a real game changer.
Section 4, The AI Ingestion Pipeline, turning files into facts.
So how exactly does an uploaded resume navigate this system to actually become a verified profile? Well, it goes through a highly structured workflow. First up, the upload. Second, BullMQ steps in and dispatches this to a TypeScript worker. Third, the data gets processed by 5 distinct extraction agents running on that local Ollama setup to meticulously pull out projects and experiences. Fourth, those extracted skills are automatically marked as accepted. And finally, they are committed to the live PostgreSQL profile. It's seamless. Unstructured text comes in, and a structured database record comes out.
But here is a really vital engineering reality that you have to account for. Those 5 AI extraction agents, they run sequentially, not in parallel. And you might be wondering, why slow it down? Well, because a single shared local Ollama instance would absolutely thrash under concurrent calls. It would run out of memory and crash hard. By forcing each stage to just wait its turn, the architecture prevents the local runtime from buckling under heavy load. Sure, it takes a bit longer, maybe 2 to 4 minutes, but it guarantees stability.
Section 5, RAG, chatting with profiles via retrieval augmented generation.
Once all that data is ingested, recruiters need a way to actually query it. And instead of relying on the model's parametric memory, where an LLM might just hallucinate facts about your career, SkillsHome utilizes a very strict RAG implementation. It fetches the exact AI-verified chunks of your living profile to ground the model's output. This ensures the recruiter gets highly accurate answers that are directly tied to your real data, no making things up. To actually retrieve the right chunks of your profile, the system relies on cosine similarity. When your profile is ingested, your skills are converted into embeddings.
Then, when a recruiter searches, their query is also embedded. The system then ranks the semantic closeness of those two vectors. Basically, this means it matches the exact intent and meaning of the recruiter's query to your profile, even if they aren't using the exact same keywords you used.
Section 6. Real-world engineering truths. Ideal docs versus shipped code.
Okay, this is where the shipped code goes totally off script from the idealized diagrams you usually see. You would probably assume a complex RAG setup like this requires some trendy, dedicated vector database, right? But in a brilliant display of pragmatic simplicity, there is absolutely no separate vector database here. The RAG vector chunks live entirely inside Postgres as standard float arrays. They're calculating that cosine similarity in plain application code by just doing a full table scan. At their current scale, it works perfectly, and it drastically simplifies the deployment.
These edge cases really reveal the gritty reality of building AI products. We already talked about the sequential agents preventing hardware thrashing. But check out these fallbacks. If a cloud LLM API throws a 402 out of credits error, the system actually silently fails over to the local Llama instance mid-call just to finish the job. We also see some very clever data management masking tech debt. For example, a stale job guard uses an update many command, so if a Postgres row is already deleted, it just updates 0 rows and entirely prevents a crash. And honestly, my favorite one, the clear stuck jobs admin button. It updates the database to mark jobs as failed, but it doesn't actually drain them from the Redis queue. It is purely a pragmatic, duct tape workaround in production.
Seeing exactly how SkillsHome leverages local LLMs in this pragmatic, boots-on-the-ground engineering to protect data leaves us with a really powerful takeaway. As AI inevitably ingests more and more of our professional lives, we have to ask ourselves, will your personal brand be built on and ultimately owned by massive corporate cloud servers? Or will it be secured forever on local machines where you maintain ultimate sovereignty? It's a profound architectural question, and it really forces us to consider just how much control we demand over our own identities in the age of AI.